This is a tutorial on how to complete the element project. We'll start at the main website, the ChemStoked website. You'll need to find the element project listing under the resources. If you go to resources by chapter/unit, and we'll see the link right here. The first place to go is the project description and rubric. Read through this carefully. The project will consist of a fact sheet, a description of the fact sheet, and a model. So the key thing about the fact sheet is that the facts mentioned on the fact sheet should be connected to the properties that result from the interaction of protons, neutrons, and electrons. So the key idea here, what I'm looking for, is that you are drawing connections between the structure of atoms and the properties, the characteristics that result from that. And then not only are you going to describe the properties that result on a smaller scale level, but you're also going to describe how those characteristics lead to large-scale observable features. And I'll go through an example of this in just a minute. The model is a physical wire model, and so I will show examples of that as well. It will be similar to the Bohr model. So read through the rubric here carefully. The rubric is broken down into the fact sheet, the model, the description of key properties, works cited. Excellent work is to do everything it says to do, and to do it where it even exceeds the requirements. So if it just barely meets the requirements, then it moves it over into this C or B category. So make sure you're doing everything it says to do there. If anything is missing, then points will be lost for that. Notice there is an extra credit option here as well. And so you can produce a video of your project to present it. So let's take a look at, let's do an example of how to construct this project. So you'll need to enter the choice of element here, and the fact sheet, I give you a template. You can download this template. If you go to File, you can find a download as, and you can download it as Word. Or you could also save it to your drive. If you have Google Drive, which is what was used to create this, you could save it to your drive, and then you could edit it on there. One of the nice things about using Google Drive is then you can share it with your group or your partner, and then you can both edit it at the same time. Notice there's a few other websites here. ptable.com is a great starting point. We'll use this to get a lot of the information for the fact sheet. And then the MLA citations, you can use this link. Why don't we try an example of how to do the project. So I'm going to start with the fact sheet. And so I'm going to make a copy of this so that I can edit this. Alright, so let's do hydrogen. So I need to get this information up here. And by the way, I don't want you to do hydrogen for your project, since I'm going to go through this example with you. So here's hydrogen. We can use ptable.com to get information about hydrogen. The atomic number is 1. And then we have its atomic mass down there, the 1.008. So let's go ahead and put that on here. Anywhere you see brackets on the fact sheet, the brackets need to be taken out. So you can just double click, highlight like this, and then the brackets will come out. Actually, triple click If you double click, it'll highlight a word. If you triple click, it'll highlight the whole sentence. Now this model key down here, after you construct the model, you'll need to list the color that you use for the beads. So we, although there is some variation with the models, typically it's done with beads and a fishing line and then wires to show the electron energy levels. So the key will be put down here after that's finished. So we identify whether hydrogen, the class, whether it's a non-metal or metalloid. You can find that on the dynamic periodic table. There's a few ways to do that. First of all, notice it has a key over here. So right here, the non-metals has a key. If I put the mouse on it, it changes colors. And so it shows hydrogen is the green, which the key says is an other non-metal. So we know just from that hydrogen's a non-metal. So we would put that information there. The common name, not all elements will have a common name. So like these ones, see the alkali metals, the alkaline earth metals, they're in the yellow. Transition metals, post-transition metals, noble gases, halogens. So we have some that have common names. Not all of them will. So if it doesn't have a common name, that can be left blank. The state of matter. One way to find that on ptable.com, if you go up here to the properties tab, we can look up the state at 273 degrees Celsius, which is all, or, I'm sorry, 273 Kelvin, which would also be 0 degrees Celsius. This is a unit that we haven't quite gotten to yet, the Kelvin unit. So 273 Kelvin is 0 degrees Celsius. Basically, you just add, so in order to find the Kelvin temperature, you just add 273 to the Celsius temperature, or in reverse, you subtract 273 from the Kelvin temperature to get the Celsius temperature. You can even change the temperature here as well. But so notice at 273, it says that, so if we click on hydrogen, it will say what state hydrogen is. You can click on other elements too, and it will say what state they are, right there in the yellow. So if I click on hydrogen, it says it's a gas. And if I do this here, let's see, there's a key as well. So notice that hydrogen is under the key as a gas. Something that's kind of interesting is you can change the temperature here, and you can see how that state of matter changes with different temperatures. So we would put that information there, the state of matter. The melting point and boiling point can be found in that same place under the properties of matter. Here we have the melting point and boiling point. We'd want to change that again back to 273. And those temperatures are given in Kelvin once again. So basically, if you want to know the Celsius temperature, you'll need to add 273. I'm sorry, subtract 273 from that temperature. So it's going to be a negative, since hydrogen is such a has such a low melting and boiling point. It's a gas. It's going to be a negative number, negative Celsius temperature. All right, so we can look up other information here, like density as well. That's under the right there. You can just click, and there we get the information. The radius, as you're also asked for the radius, and there's a few different options here. You can just go with the calculated option, but you'll notice that it changes a little bit based on which one we pick. And I believe there's also information about ionization on there, ionization energy, and electronegativity shown here as well. with a comparison to other elements there with the color key. So that will get a lot of the information you need here on the fact sheet. Information about isotopes you can find by clicking on the isotope button. So if you click on the element, it pops up with the different isotopes available, and you'll be showing that the isotopes in the correct format. So either you could do it by writing the name like this, followed by the mass numbers of the isotopes. So that for hydrogen we have mass number 1, 2, and 3. Oops, wrong one. Hydrogen 1 dash 2 dash 3, that would be acceptable. You could also do that with the symbol, or do it with the format where you put the mass number as a superscript above the symbol. So you could do it like this, 1H. And if you're working on Google Drive, to do a superscript, you can do control and period, highlight it first, and then control period. Oops, wrong side. There you go, like that. If you're working with Microsoft Word, then it's control, shift, and the equal sign will make a superscript. So there's different ways to do that. Alright, so chemical reactivity. You can look on p-table at information about compounds that the element forms. That might give you some information, but there can be quite a long list, and it's difficult to generalize from such a list. You might be better off going back to the main page here, and when you click on the element, it brings up a Wikipedia article. And so this would probably be better for getting some general information about reactivity, and the information also about the number of bonds it forms and the types of bonds it forms. Probably going to want to look more so in this this type of area. So you'll also get a picture of the element. You might get that here from Wikipedia. And when I say picture, I want an actual picture, like something like this, as opposed to like an artist drawing of the element. Unless there are a few elements that we should be able to find pictures for the ones that we're doing. There are some synthesized elements, of course, but I don't recommend you do any of those elements for this project. Now, the illustration of orbitals. Oh, notice you need to provide an in-text citation for your sources. So, like, if I did the picture of hydrogen here, I would need to cite the Wikipedia article. Now, one of the nice things about Wikipedia here is if you go to Media Viewer, go to Copy, just right-click, go to Copy, and it says you need to attribute the author. It will give you a citation right here that you can copy. So I'll accept that that citation. That will go into your works cited section for the project, but then you'll need to also provide an in-text citation. So like for this one, the last name of the person is apparently alchemist. So you'd put alchemist, and I don't think there's any other information, so you just put that in parentheses on your in-text citation. So whatever information you're able to find there for the source, that's what you'll include. The illustration of orbitals. What I want you to do for this is I want you to go back to the dynamic periodic table and go up to the orbitals tab. Now right here, see where the mouse is, it will make a a picture or an illustration of what the orbital's structure is. So as you scan through the different elements, you can see some pretty interesting structures that form with the orbitals. And so I'm going to have you guys copy that. Now, there's a technique involved in this though. So in order to copy this, so like if I'm doing hydrogen, I can click on the element, so it kind of locks it in place after I click on it. And then I'm going to need to, it won't let me just copy it if I right click. So what we're going to do is we're going to print the screen. You can basically copy anything on a computer, anything on your screen. Just find the print screen button on your keyboard. So you press that, press that print screen button, make sure it's locked on hydrogen or whatever your element is. For me it's hydrogen. Alright, so now I'm going to go back to the element fact sheet, and now I paste the screen. So it copied the entire screen. Now I don't want the entire screen on there, of course, so I need to crop this. So I need to find the crop button. Where is that? Here it is. It's in a little different spot on Microsoft Word. And I'm going to crop everything out except for just that illustration of the orbital. And then I'm going to resize this as well. So I grab the corner here, resize. And we can take out the brackets here. And there we go. So hydrogen's orbital looks like that. Then you also need the electron configuration. So you might notice that you can use a similar technique. As you click on these elements, it provides an orbital diagram here, or off-bow diagram of the electron configuration. And then you should also include the shorthand, which it also provides for you. So you can use a similar technique and print the screen and include that into this place right here. So like if I did that, printed the screen, I could crop once again. Okay, yeah, so you have to click on the image to crop it. You click on the image, then the crop button comes up, crop down. And so I'm just going to include here this information. And then you also need to include the shorthand electron configuration. So that's going to be this right here, 1s1 for hydrogen, or 1s1 for hydrogen. Alright, so that's a rundown of the fact sheet and how to complete that. Now look closely at the requirements. Let's pull those up again. So the description of key properties, this is the biggest value placed on this area. So the description discusses how interactions of electrons, protons, and neutrons cause key properties. Key properties may include chemical reactivity, types of bonds formed, number of bonds formed, electronegativity, ionization energy, atomic size, isotopes, metallic character, and magnetism. It also explains how several observable macroscopic, meaning large-scale, features result from these properties. So what I want you to do now is I want you to look at those properties that you listed in the fact sheet, and I want you to explain why those properties are what they are based on what you know. You may look up some information on this as well, but a lot of this can be explained in terms of the electrons. So for instance, why is hydrogen, why is its electronegativity about, I think it's 2.1. So it's not the lowest, it's not the highest. Why is that? Why is it reactive? Hydrogen, for instance, is very reactive. It reacts with organic compounds. It is involved in acid and base reactions. It can react with nonmetals. It can also react with metals. It can react covalently as well as and with ionic character. So hydrogen, perhaps we can explain that by its one valence electron. It needs to get that one more. Its size also is a factor in its ability to form strong bonds. So as we discuss the types of bonds it forms, we're describing why those bonds form. Density has to do with the structure in which hydrogen forms. So since hydrogen forms diatomically, meaning that it bonds with another hydrogen, and it is very lightweight, it is a gas with as a diatomic molecule with little attraction between other hydrogens. So we look at these aspects. Isotopes. Here's another one. So for isotopes, you're going to describe, well, what is the cause of those isotopes? Why do we have these different isotopes? And so, of course, that has to do with the number of neutrons and protons relative to protons. So you're going to describe that. It might be appropriate to describe for some elements why they are stable or not, why certain isotopes are not stable. So for instance, as we get further down the periodic table, the elements become larger and larger, and the nucleus can become less stable. So for instance, radon gas is radioactive because its nucleus falls apart. It's not stable enough. So we might describe aspects like that. So it's important to discuss as many of these properties as you can, as many things as are appropriate. Metallic character. So that's metallic character, for instance, is how likely atoms are to give up their electrons, similar to ionization energy. Magnetism has to do with the electron configurations. So in particular in these elements like iron, where their electron configurations are unbalanced in the d block, the arrows that are unbalanced can lead to magnetism. So we have spins going in one direction only. So that would be another property to discuss. Now I want you to take this a step further. So the description also explains how several observable macroscopic features result from these properties. So I just gave an example of magnetism. So because of the way the electrons are arranged, this atomic property of the electrons, leads to an observable property that we can see by just simply looking at iron. Hydrogen, because of its density that results from the way it's a diatomic molecule with few attractions between other hydrogen molecules, it results in hydrogen being a gas. So I want you to take it a step further, and for a few of these properties, describe what observable features we might note from those things. Let's see if there's some other examples here. So, for instance, electronegativity. A highly electronegative element, we might describe how it is very prone to forming compounds. And so it might rarely be found isolated, or one with no affinity for electrons, or essentially no affinity or attraction for electrons like the noble gases, doesn't form compounds, so they remain as gases. The last things to note here, of course, keep track of your works cited, spelling, mechanics, and academic language. Let's talk a little bit about the model. So the model, there's a description of how to do the model. And so the model is kind of like the Bohr model. And so you'll be putting representing the protons and electrons with the beads, and then you'll run fishing line through them and use wire loops to represent the electron energy levels. And I'll need to show an example with this, so I'll attach that to the examples you have.